Lesson 15 is a short lesson, but a little bit more about proofs. A lot of this is review. It's things we've already talked about. Part of it is cautions about a couple of mistakes that I see way too many times. So, perpendicular means things meet at a right angle. They make a 90-degree angle. So if you have a statement that is given, AB is perpendicular to CD, that means you can mark on the picture that those form a right angle. It means that in a proof, you can say angle ABC is a right angle, and your reason is definition of perpendicular. It means you can say angle ABD is a right angle, and then you put definition of perpendicular. It means you can say that the measure of angle ABC equals 90 degrees, or the same thing for the measure of angle ABD. Definition of perpendicular. All that perpendicular means is 90 degrees. Just waiting on a couple to finish writing. Midpoint means dividing into two equal pieces. We can have a segment and the midpoint divides it into two congruent parts. So if B is the midpoint of AC, that means we know those are congruent. So we can write in our proofs, AB is congruent to BC, definition of midpoint. Now on my next slide, I'm going to talk about a mistake that I see over and over and over. And I'm trying to warn you so we don't make those mistakes, so we don't lose those points, Jack. No, this isn't something for a formula list. This is just an example of a line in a proof. So here's where the problem comes in. Perpendicular does not mean bisector. Now, most of the time, you're going to have a picture where you're proving congruent triangles. So this is going to come down to the midpoint, but they do not tell you that it's the midpoint. If you're given perpendicular, you can only talk about the 90-degree angle in there. Then you go through the other steps, you get the congruent triangles, then you could say CPCTC to say the left part is congruent to the right part. But you've got, if all they tell you is perpendicular, you've got to get to congruent triangles before you can talk about it being the midpoint. And the reverse is also true. Midpoint or bisector does not mean perpendicular. You can have something that comes down like this. Even if it looks perpendicular in your picture, it might be off just 1/10 of a degree. If it's 89.9, it is not 90 degrees. It is not perpendicular. So if it says midpoint, you can only talk about the pieces being congruent. If you got to congruent triangles in a proof, then you could say CPCTC says that those angles would have to be congruent and then that it would have to be perpendicular. But be really careful with that because I have students every year losing a bunch of points on that. Questions? Okay, just a couple other things to quickly review here with you then. We can also bisect angles. That simply means we have a line or a ray or a segment that divides an angle into two congruent parts. So these would be congruent angles. So if we are given that AB bisects angle CAD, that means we can write in our proof angle CAB is congruent to angle DAB, and our reason would just be definition of bisect, much as what we saw before. And I'm going to review again on the isosceles triangles because sometimes we just need to go over it more than once before it really sticks. So we've seen this before. If we have isosceles triangles, if we have one triangle and we know that two angles in that one triangle are congruent, then we're talking about one isosceles triangle, and we can say that the sides opposite those are congruent. Definition of isosceles triangle, and we are just abbreviating that with IT. You may have other lines going through this triangle ABC to divide it into smaller triangles. You're not talking about definition of isosceles to get an angle or a side in one of those little triangles compared to an angle or a side in another little triangle. If you use IT, you have to just be looking at one triangle, so ignore any lines that go through it. And as we saw the other day, it goes the other way. If we start out knowing the sides are congruent, then we can write in our proofs that in that one triangle, those opposite angles are congruent, and that is definition of isosceles triangle. Anybody with questions on that? Most of that I know was a review today.